Good evening, ladies and gentlemen. Thank you very much for giving me a voice. I would like to discuss my work, my resume of research achievements about hydrogen retention time. Yesterday I was talking about Iranian version impact bad. Today I will talk about wastewater of paperwood. I would talk about anaerobic starch blanket, which is another part, how it's used. And this is based on work of Archimedes Cruz Lopez from Mexico University of Nueva Leon. And this work was published in Biomass Conversion Biorefinery, entitled Continuous Dark Fermentation in Industrial Food Wastewater, the Effect of Hydraulic Retention Time on Hydrogen Production and Microbial Variation. The idea is to use food wastewater coming from cheese wastewater, so containing the much of waste and the other waste is bread residual. So this is the composition of lactic acid, lactase, and starch, which is totally different than starch paper, because starch and whey are already treated waste. Very good and very estimated. And then where is used as this material in compared to paper, which is very hard, needs to be hydrolyzed. It needs only to be milled and to be digested. There are not any structure because are already mixed, are already easily to soluble. But still is very, very big ways that if not digested, especially this way, will provide to bacteria and fungi, bacteria blooming, which can be quite waste. Therefore, cheese waste is very important to use with fatty acid. As I said, fatty acids are very important lipids, even more for dark fermentation. Dark fermentation, in this case, is going to butyric acid to natural pathway, butyric acid. However, I say the waste is going, if without hydrolysis, straight to be utilized by bacteria. This bacteria, in this case, in case of paper, we don't have any ideas, only I think treatment. He and the bacteria was for wastewater. He is also for wastewater treated, but here is pH of 6 as terminated, so as similar, useful, quite good for hydrogen. of pH of 5 or 5 even, between 5 and 6. But intercooling was before using heated for 100 in water bath and cooled down at water temperature. No, and this is showing the fermentation process. The reactor had height of 300 millimeters in case of cheese wave wastewater. The reactor has built such that bottom is blanket with stripping on the top of hydrochloric acid to keep this pH 5.5. The pH was measured and chemical oxidation demand as the volume of efficiency. In case of paper, we have no ideas. They don't give us pH 7. That's we have different cases. The hydrogen production was checked using gas chromatography with thermoconductivity detector as most suitable and most carried. This allows you to separate gases product in 240 to 430, and this gives us hydrogen, carbon dioxide, and methane as product. They also give some salts, phosphorus, and to use. What is difference? Difference is that hydrogen was not 40% like paper, but 60 to 70%. It wasn't big, but the effluent pH was from 7 and keep after cycle to be similar to 4 to give 5.5 keeping. The hydrogen daily by cycle was different because here we have from in case of paper from 1 to 8, 24 hours, and what 24 hours was the was. In case of waste, which were mixed and used, we have 3, 8, and 12 hours. And in case of 3 hours, was also the is somehow where some strike in second and 18 cycle. We don't have such in paper. But in most overall, the most suitable was 8 hours. So as you see, in case of paper, you can also use only 1 to 2 hours in case of packing. So fluent. In this case, in this reactor is catching and flowing by cross flowing, not flowing with reactor bed and not such area. But as we see, there's not such areas. Peak of reaction shows that longer time can stay and is useful on overall medium. The only is that we don't have only 60%, while in 3 hours hydrogen retention time, so how much time will stay this substrate, is that there are some jump with 70%, but mostly goes to 40%. It's much better than in case paper, but paper is much lower because not only 30% was converted into to fuel. As we see, the organic removal matter in case was the lowest in case of 3 hours and the highest in case 12 hours. We see that removal is up to in case of 12 hours up to 90% of waste. So we have to decide in paper, in wastewater, and choose way to what to choose, high hydrogen or high converted. I think that little is still not enough, so bet more will be too longer, not too shorter. But 8 hours should be very rational between high conversion, because 70%, and then return back this flow, and in such cycle, recycle, and this fatty acid can be used also as polyalkoxylates for polymers. Is the other way. We don't have such measurements in paper, showing to this professor of Abdul Rahman what they should make that higher, wider analysis of such products. In this case, in case of 8 hour, was 368, which liters per 1 gram of waste, which is 2 times higher, 3 times higher than in case of paper. This shows that it is much cheaper and much uh, efficient to use wastewater than paper. But still, paper is big trouble because it needs to decolorize. So wastewater from this way and wet wastewater is very good matter, much more promising as waste. And more focus in such plans should be on this. So thank you very much for listening me. Thank you very much. I recall